Good day, students. So today we'll be focusing on plotting functions, and I have two questions that I would like to present to you and work out so that you can view. So our first question, part A, says copy and complete the following table using the equation y is equal to 3x plus 5. Now y is equal to 3x plus 5 is a function, but the way it's written there is what you call the defining equation for the function. Y is equal to 3x plus 5. This is the defining equation. The function form will be f of x is equal to 3x plus 5, but it doesn't matter. I use y simply because I'm using the function table, and the function table, instead of having your domain, your range, you have your independent variable, which is x, and your dependent variable, which is y. Okay, so these are the values that we are allowing x to be. So x ranges from -4 to 5, right? These are the values alone. So now we just have to find our y values that correspond to the particular x values, those that are missing. Okay, so what I want you to do is try to work this out. I believe you can do this already. Start now. You can pause the video. Okay, so hopefully you are done. So I've copied the table, and let us use our function, which is y is equal to 3x plus 5 to complete the table, right? Okay, so you don't have to do this, but first let us verify that -4 pairs with -7. Right, so let's use our function. We're saying that whatever x is, the y value is 3 times x, 3 times that value plus 5, right? So once x is -4, the y value has to be 3 times -4 plus 5. Let's see if that'll give us -7. So I'm gonna write when x equals -4, y is equal to 3 by -4 plus 5, 3 by -4 plus 5. So 3 by -4 is -12 plus 5, -12 plus 5 is -7. So this is accurate. Okay, so now let's do for those that are missing. So when x is -3 now, y is equal to 3 by -3 plus 5. 3 by -3 is -9. Positive by negative is a negative. So that's -9 plus 5, which is -4. So here -4 goes. Okay, so for -1, when x is -1, y is equal to 3 by -1 plus 5. 3 by -1 is -3. -3 plus 5 is 2. If you owe $3 and then you give the person 5, they'll give you 2 back. Okay, so -1 gives us 2, right? Let's do for 0. When x is equal to 0, y is equal to 3 by 0 plus 5. 3 zeros are 0. 0 plus 5 is 5. Okay, so I went ahead and completed the rest. There is the working. When x is 0, we have 5. When x is 2, y is 11. When x is 4, we have 17. So this is our completed table. This is our completed table there. Okay, so let's go back to the question. We finished part 1 of question 1. Let's look at part B. So part B says to plot a graph to represent the information presented in the completed table, right? So this is our table, and we have to plot a graph to represent this information. So before we go to the graph sheet, what I want to do is, in fact, before you try to plot any graph, the first thing you should do is analyze your table, right? You need to look at your table, because the Cartesian plane is what you plot in your graph on, can be arranged in many different ways. You can have the Cartesian plane going like this. You can have the Cartesian plane going like this. You can have the Cartesian plane like this, or you can have it like this, or many different things. You can even have it like this, right? Now, the way in which you draw the Cartesian plane depends strongly on your data set. Okay, so we have our independent variables, and we know our independent variables, which is x, goes on the horizontal axis, the horizontal x-axis, right? Another name for the x-axis is the y is equal to 0 line. That's all the points where y is 0. So this is our horizontal x-axis. So this is our x-axis as well. Our x-axis, the horizontal line, is always the x-axis. And even this is our x-axis. Now, the intersection, the vertical one is the y-axis, by the way, right? So this is our y-axis, and all the vertical lines are our y-axis. Now, the intersection of the x and the y-axis is reserved for 0. That's where 0 begins, right? And it's important that we identify where 0 is. 0 is the intersection between the y and the x-axis. So that's where we begin counting our numbers. So this is 0. All the numbers to the right, of 0 are positive, and all numbers to the left of 0 are negative. So when I determine my scale and I start scaling my x-axis, the next number after 0 will be a positive number. 1, 2, 3, 4. We start counting from 0, right? So that means all numbers here are positive, and all numbers here are positive as well. All numbers above 0 are positive. All numbers to the right of 0 are positive, all numbers above 0 are positive. All numbers below 0 are negative. So 0, -1, -2, -3, and all numbers to the left of 0 are negative. So -1, -2, -3. Now for this one, all numbers to the right of 0 are positive. So we have 1, 2, 3, 4. All numbers above 0 are positive as well. So 1, 2, 3, 4. For this one, to the right, positive. 1, 2, 3, 4. Above, positive. Sorry, to the left, negative. -1, -2, -3. Above, positive. And so on for the rest. So this is 1, 2, 3, -1, -1, -2, so on. This is 1, 2, 3, 4, and to the left of 0, negative. -1, -2, -3, and so on. Now the scale might change the way I read number, but that's not what the focus is on now. The point is, this one, the x-axis has both negative and positive values. The y-axis as well. The y-axis has both negative and positive values. For this one, the x-axis only have positive values, when the y-axis only have positive values. For this one, the x-axis has both positive and negative, but the y-axis only has positive values. This one, x has both positive and negative, but the y-axis only has negative values. For this one, the x-axis only has negative values, and the y-axis only has positive values. So we can choose to draw either type based on our information, right? So we need to look at our information. and which is there, and we look at the range of values that we have. So we can see that x ranges from -4 to 5. So since x has negative values, we need to cater for them. That means that this one is a no-no, because this one, we have no negative values to cater for on the x-axis. So we can't use this one. We can use this one, right? Okay, so let's just eliminate first. We can't use this one. And since x has positive values, and this one only has negative, we can't use this one either, right? Now let's look at y. Y has both positive and negative values. Negative here, and we have positive there, right? So which means we can't use this one, because here y only has negative values, y doesn't have any positive. So we can't use this one. Let's see, can we use this one? Y has negative values as well, so we cannot use this one. So this one is more ideal. A graph like this is more ideal. Why? Because this one caters for the positive values of x and the negative values of x, and the same for y. It caters for the positive values of y here, and will also cater for the negative values of y, which is there. Okay, so now I'm getting ready to draw my graph. So what I have there is the graph paper, and this is the one that is recommended. Okay, so on our graph paper, we can see that we have horizontal lines, and we also have vertical lines, and they intersect each other at right angles, right? They intersect each other at 90 degrees. Because when a horizontal line intersects a vertical line, you'll have a 90-degree angle. Okay, so as we can see, the intersections make different size squares. So you can see we have the dark lines, they intersect, right? They intersect here, and they make this big square. And you can also see smaller intersections, right? So we can see that this big square is actually divided into 1, 2, 3, 4 smaller squares. And even further, it actually has 1, 2, 3 these tiny squares, right? Yeah, so that's the graph paper for it. Now the length of each large square is 2 centimeters. So distance between there and there is 2 centimeters, and half of that is obviously 1. So the distance from there to there is 1. Now 10 small boxes, these tiny boxes, 10 of them together will actually make up this 2 centimeter line. So let's count. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 of them together makes up 2 centimeters. So that means that the length of one will be 2 centimeters, or 20 millimeters divided by 10. So that's 2 millimeters. So each small box represents 2 millimeters. So if each small one represents 2, 5 of them will make up 1 centimeter. Like I said, so 1, 2, 3, 4, 5, that's 1 centimeter. So this is it's important to know that, because it will help you to draw your scale properly. It means that you do not really need to have a ruler to draw your scale, as long as you know that the distance from here to there is 2, the distance from half of that distance is 1, and the length of the tiny one is 2 millimeters, of which 5 of which makes 1 centimeter. You are good. You just need to draw your lines from there. Okay, so we need to decide on, let's go back to our data set, right? So we have our x values, we have our y values. realize that we have both negative and positive values for y, right? Now we can see that x is as negative as it is positive. In other words, negative 4, in other words, we go below 0 the same amount, well, almost the same amount as we go above 0. That's for x. And remember, our x-axis is horizontal. So what that means is, since we go, I should not say below, since this is our horizontal line, we go to the right and we go to the left. We go to the right of 0 almost the same amount as we go to the left. Right? So what that means is we should try to put our intersection somewhere in between the graph, right? So let's count. 1, 2, 3, 4, 5, and we have 1, 2, 3, 4, 5. So let's see. Yeah, somewhere around here, in between. Since it's not really exactly half-half, we can just leave the extra space for the right. Okay, so I'm going to draw my x-axis. Okay, so I went ahead and draw. Sorry about that. Okay, I went ahead and draw my axes, my Cartesian plane. So we have the y-axis and we have the x-axis, right? It's important to put your arrows because it means that it goes on to infinity and negative infinity and beyond. It's also important to label your axes. So you have x and you have the y-axis. Okay, and identify where 0 would be. Okay, so like I said, I drew it like this, right? Because I have to cater for positive values and I have to cater for negative values. Same for the y. I have to cater for the positive values of y and I have to cater for the negative values of y. The reason why I draw the positive side longer, much longer than the negative side, is because we have to go all the way to positive 20 on our y and we only have to go down to negative 7, right? So we need more space for our positive values on the y-axis than the negative values, right? Okay, so now we need to look at a scale. The scale helps us to really size our graph. So for the x-axis, we need to cater for negative 4 to negative 5 on this space there. So I can go 1 centimeter is to 1 unit, 2 centimeters is to 1 unit, 1 centimeter is to 2 units, right? So that these are the 3 different scales. So let me write 3 different ones and let's see which one is the best. So 1 cm is to 1 unit. We can use 2 cm is to 1 unit. And we can also use 1 cm is to 2 units. And any other combination, you can have 1 centimeter is to 5, 5 centimeters is to 1. It doesn't matter. Let's just look at this. So if you go 1 centimeter is to 1 unit, let's see if we can represent all the data we have there. So each centimeter, remember centimeter is half of the big block, half of the side of the big block. So that's here. That's 1 centimeter. So if you use 1 centimeter to 1 unit, you have 1, 2, 3, 4. And our graph stops here, right? And then we have to go to 5. So 1, 2, 3, 4, 5. Our graph stops here. And 4. The negative ones, negative 1, negative 2, negative 3, negative 4. The graph stops there. Now this is not ideal because we need to draw a graph to represent a wide range of values. We need to draw the graph, such that it takes up a big space, as much space as possible. We don't want to waste graph. If we use 1 centimeter, 1 unit, we end up stopping here. We want the graph to take up as much space as possible. So this one is good because in that allows us to put all our values, but it's bad in that it doesn't take up as much space as we would like it to. So let's try 2 centimeters. In fact, let's skip 2 centimeters. Let's go to the third one. 1 centimeter is to 2 units. Let's see. So if you go 1 centimeter is to 2 units, we have 1 centimeter, which is here. We go 2. So 2, 4, 6, and 5 will be somewhere in between there. So that means our graph stop here. We have 2, 4, right? Our graph is only that small space. That cannot be, we cannot have this one either, right? Because we need our graph to take up as much, the most space as possible, right? So we can't use this one. So let's try 2 centimeters now is to 1 unit. So for every 2 centimeters, that's the distance from here to here, we put 1 unit. So this is 1, 2, 3, 4, 5, right? So it took up that entire space, which is what we want. We want to take up as much space as possible for to draw to put our values for the x-axis, right? So it took up as the most space as possible. So we'll use this scale. So here we do 2 centimeters to 1 unit. So 2 centimeters, 1. Another 2 centimeters, second unit, another 1, another 2. That's a third unit, fourth unit, and fifth unit. For this one, -1, -2, -3, and -4. Okay, so this is the ideal one because we're taking up as much space. We're maximizing our space. We're not wasting the graph paper. We want the graph to be as big as possible. So this is our best scale. So let's look at the scale for the y-axis. So let's look at this again. So for our x-axis, we saw that this one was the best for our x-axis. So let's look at our y. This one was the best. Okay. So if we decided to use 1 centimeter is to 1 unit for our y-axis, let us see if we can cater for 20, right? So if you go 1 centimeter is to 1 unit, let's see if we can cater for 20. So let's see. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. We cannot cater for 20 because we stop at 16. So this 1 centimeter is to 1 unit for the y-axis is also not ideal. It can't work, in fact. So let us try 2 centimeters is to 1 unit. Let's try 2 centimeters is to 1 unit. Let's go. So this is 2, we put 1. So this 1, 2, 3, 4, 5, 6, 7, 8. We can't cater for 20 using that scale. If we have to cater for 20, we still have to continue, right? But we can't cater for it. We need to represent all our data on the graph. So this scale is also not ideal. Now what about 1 centimeter is to 2 units? Is that the perfect match for our y-axis? Let's see. So 1 centimeter is to 2 units. So every time we go 1 centimeter, we put 2, right? So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, right? So we can, even though we still have a little bit of space left, it doesn't matter. This is the best we can do. So we can't cater for 20 using that scale. So our ideal scale is 1 centimeter is to 2 units for our y-axis. Let's see if it will help us with the negative values. Remember, we only have to go to -7. So let's see. -2, -4, -6, -8. -7 will be in between these two there. Right? Okay. So we can cater for all our data values for the y-axis. So let's do that. 2, 4, 6, 8, 10, 12, 14, You can also put more, it doesn't matter, even though you don't need to put it. Okay, so we have our x-axis, we have our y-axis, we have our scale, right? So now it's just time to plot our data, right? So we go back to our function, and then we make our list of ordered pairs from that. So let's call point A, we'll take -4 and -7, so that's -4, -7. Point B, -3, -4. Point C, -2, -1. Point D, we'll call it point D, -1, 2. 0, 5, 1, 8, 2, 11, 3, 14, 4, 17, 5, 20. Right, so these are our points A to J, and we are going to plot these points. These are our ordered pairs, that's what they are called. We're going to plot them on our graph. So we know the first number represents our x value, and the second number represents the y. Okay, so we're going to plot -4, -7 first. So we go -4 on our x and -7 on our y-axis, which is in between -6 and -8. So that's this point there. When you plot in points, you should not be shading. This is not acceptable. This, what else is not acceptable? This is not acceptable. You can either put a point with a circle, right? Your pencil must be sharp. As you can see, mine is sharp. Or you can just put an X, right? This is unacceptable, this is unacceptable, this one is right, this one is right. So you can use either of these. Okay, so this is point A. Now point B is, let's take a point B, -3, -4. So -3 on our x, -4 on our y. So that's this point there, right? Point C, -2, -1, -2 on our x, -1 on our y. -1 is in between 0 and -2, right? Directly in between. So that's this point there. This point B. That's point C, sorry. So then we have -1, 2. -1 on our x, 2 on our y. Notice all these points fall in a perfect line, perfectly straight line. So then we have D, 1, 2. Sorry, we did D already. Yes, D was -1, 2. E is 0, 5. So 0 on the x, right? 0 on the x and 5 on the y. And that's why it's located on the y-axis, because remember I said the y-axis, another name for it is x is equal to 0, right? So all points that fall on the y-axis, the x coordinate, the first number, is always 0. So this is why E, 0, 5 is along the y-axis. So we have F, 1, 8. 1 on the x, y and the 8 on the y, sorry. Then we have g, 2, 11. So 2 on the x, 11, which is in between 10 and 12 on the y. H, 3, 14, 3 on the x, 14 on the y. I, 4, 17, 4 on the x, 17, which is in between 16 and 18 on the y. And finally, we have J, 5, 20. So 5 on the x and 20 on the y. So let me continue labeling. So this is E, 0, 5. This is F, 1, 8. This is G, that's 2, 11. This is H, which is 3, 14. And this is I, which is 4, 4, 17. And this is J, which is 5, 20. Okay, so these are our points. So all that's left is to draw a straight line connecting all the points together. Right? That's all that's left to do. Okay, so also I need to add that you also need a title, right? So our title here is graph showing the representation of the function y is equal to 3x plus 5. So right, this is our straight line, our points. We have our, make sure we have our scale, make sure you label the x-axis, make sure you label the y-axis, make sure everything is perfect. I just want to point out that our scale means that the distance between each unit should be the same everywhere. So if this is 0 and 1, right, the distance, which is 2 centimeters, should be the same. So between 0 and 1 we have 2 centimeters. Between 1 and 2 we have 2 centimeters. Between 2 and 3 we have 3 centimeters. Between 3 and 4, 2 centimeters, right? So that means that you can't have a case where you have 0 to 1 and then you have 1 centimeter and all the rest are 2. Throughout, they should be 2 centimeters. And also you should always start counting from 0, right? Do not start counting from this point there. You count from point 0, and point 0 will be the intersection of the x and the y-axis. Because let's say you started counting from there, right? And you say, okay, you're going to make the 5, and you start counting backwards. You'll have negative 4 here, you'll have negative 3 here, you'll have negative 2 here. Sorry, not negative. If you make a 5, you'll have 5 here, 4, then you'll have 3, then 2, then 1, and then you have 0 here. You see? So the distance between there and there, 0 and 1, is 1 centimeter. But all the rest, you have the 2 centimeters. And it cannot be like that. So you have to start counting from 0. Positive on the right, negative on the left. For the y-axis, positive up, negative down. Okay, so that's it for question number 1.